Hello everyone. So today we'll see exception handling in Java. Uh, Effective exception handling is crucial for stable and maintainable and Java application. It prevents crashes, data corruptions, and proper handling leads to clearer error messages, significantly improving user experience and system reliability. So we'll see what exceptions are. So exceptions is in disruptive events. So it disrupts the flow of any normal execution. So where exceptions are event that disrupts the normal flow, they represent runtime errors. This includes issues like invalid input. So while executing, you are tend to get some errors if there is exception. So there is types of exceptions, which are two types. First one is checked exception and the second one is unchecked exceptions. So in checked exceptions, the compiler forces handling and in checked exceptions, uh, like the everything is checked at the time of compiling. So the examples, the basic examples of checked exceptions are IO exceptions or SQL exceptions. These ensures code robustness. And the second one is unchecked exceptions. These exceptions are checked at the runtime issues. No, these exceptions are checked at runtime and they often stem for programming errors. Null point exceptions is a common example of unchecked exception. Now we'll see why handle exception and the imperative for stability. So why should we handle exceptions? First is graceful degradation. It prevents the abnormal program termination and ensures smooth operation. So we won't get any dead end or too many errors while executing, and user feedback, which is very normal for user informs user about the issues, avoids cryptic crashes, enhances user trust. So it informs the user about whatever the issue is, so which can like gain the user's trust about this. And resource management ensures proper cleanup, guarantee closing of files and prevent leaks. So if we are using exception handling, so you don't have to worry about your information leak going to leak or it is going to corrupt, because it ensures proper cleanup and it prevents leak also. Now we'll see try catch block, core mechanism of checked exceptions. So in checked exception, in try catch block, we can like code protection. There is a code protection. The try catch block encloses codes. The code might throw an exception. It's the first line of defense in try catch block. um, so we can see here in try catch block, we um, it tells us that in this code maybe there is an exception. So it I guess like we could say it informs us in the first line of defense. So how do we handle this? So handling logic, which is the catch block, handles exceptions. It specifies a type of exception. This is where recovery logic goes. So in catch block we handle all the exceptions. So multiple catch blocks are possible. They handle different exception type. Processing happens in sequence. We'll see next one. The finally block, guaranteed exceptions. So its purpose is it contains code that must execute. This run regardless of exceptions and ensures critical operation complete. So in the final block only contains the codes which we have to execute no matter what, and this runs regardless of exceptions. However exceptions are there, it will still run. And it ensures critical operation complete. And use case, crucial for releasing resources. This includes file handles and database connections, prevents resource leaks. And then execution guarantee, execute even with return or break, ensures resource cleanup. This prevents memory leaks. So it uses return or break statements to execute. So we can see here an example in try block and finally block. The throws keyword, we saw throw and now this is throws. In throws, we actually throw an exception in it. So declaring responsibility. Method signature, used in method signatures, it indicates potential exceptions. This is a declaration of intent. So in throws, we actually throw an exception into the code. Mandatory for checked exceptions, and this is a part of, this is like type of checked exception you could say, and forces calling code to handle or it must redeclare it. API communications, signal failure points to API consumers. It adheres to like fail fast principle and transparently broadcasts error. So you can get error at the like while you're compiling, not like unlike unchecked error where you can see like what is happening or errors at the runtime. So in unchecked, we check everything while compiling, so there are less chances of having errors. So here's an example of throws keyword. This keyword helps in managing exceptions flows. It clearly communicates a method of potential to fail. This design promotes robust client code. Custom exceptions, tailoring error handling. So we'll see why should we create it and how do we create it and its benefits. So let's start with why we create it. Like to represent application specific errors, clearly defines unique error conditions, enhances domain understanding. How to create, extends exception for checked, use runtime exception for unchecked, follows Java hierarchy. So in exception we have to extend, and in checked we have to like extend exceptions, and in unchecked we have to use runtime exceptions. And benefits of these two, using these two, is it improves reliability, readability of the code, and boost maintainability, and uses domain specific types effectively. So we can see here an example, class invalid input exception, extend exceptions. So custom exception logic. These are typically enterprise application define 5 or 10 custom exception types.